Okay, so it looks like most of it that you're looking at is circle types of things. So one thing I have on there is the circle equation. And not that it's really a huge deal that you memorize like all the different parts. Mostly, for instance, definitely your H and your K, you're going to have to know when you see a circle equation that right there represents your center, except for when you actually write the center, it should be opposite sign. And then it's equal to the R value squared when you're looking at it. So let's say if I had, x plus 2 squared plus y minus 1 squared equals, let's say, 25. In Math 3, you should be able to find the center of that circle pretty quickly and easily. Remember, you're going to look at this number is going to be your x value and that number is going to be your y value. It's just when you write it as the center from the equation, you change the sign. So it's actually -2, +1 is your center. Now what you have to remember is this right here is technically the radius squared. So what you end up having to do is taking the square root of that 25, because my radius squared in this case has to equal 25. So what you end up doing is taking the square root to both sides. So in this case, r is equal to 5. So you want to be able to look at a circle equation, identify very quickly what is your center and what is your radius to it, and vice versa. If it gives you the center and the radius, you can actually find the equation. So let's say if I go ahead and pick out, or write a new one, let's see, let's get rid of all this stuff. Okay, so let's say if I had x minus 2 squared plus y minus 1 squared equals, let's say, 36. Well, again, you should be able to identify that your center is at 2, 1, and then remember our radius is the square root of that number, so the square root of 36 is 6. So that's our radius to it. You can also see ones, let me erase that off there. Let's say, sorry, I should come up with a bigger eraser. Okay, so let's say if I had x plus 3 squared plus y squared equals, let's say, 20. Okay. Well, I should usually see that the center, again, opposite sign, is going to be -3. And since there's nothing here with that y, it's just like having a 0. So it's at -3, 0. My radius is going to be the square root of 20. So sometimes it's not a perfect square, and then you break it down. So that'll break down into the square root of 4 times 5. Square root of 4 is 2. Square root of 5. Okay. It also looks like you, again, you want to go back through. I'm just going to clear this screen off. Alright, so let's say if you're given a center, let's say your center's at -5, 3, and it has a radius of, 4. Well, you should be able to come up with your circle equation pretty quickly and easily as well. So again, opposite sign of these numbers in here, so it'd be +5 and -3, and it's always equal to the radius squared, so this side would just be, in this case, 16. Looks like you also had circle equations where you were given a center and a point, so this is going to be one of your circled ones. You had, looks like, not quite sure, but one of these points is your center, and one of these points actually lies on the line. It really doesn't matter which, well, actually it does matter which one is which. Looks like this one right here was the center in your problem. So from that, since you have the center, you should be able to write the first part of your circle equation. So again, opposite signs, so +3 minus 2. The only thing is it's equal to your r squared, so you're going to have to find the radius, which means you're going to have to do the distance formula between those two. So remember your distance formula, you want to subtract your x's, so -3 minus 4 squared, plus, and you want to subtract your y's, so 2 minus -2 squared. So negative 3 minus 4 is negative 7. Negative 7 squared is 49. And 2 minus negative 2 is 4. 4 squared is 16. So let's see. Let's see. 50, 65, I think. Squared is 65. Okay. So technically, that's what my R value is. So this equation is going to be equal to your R value squared, because that's what the circle equation is. And what you'll notice is the square and the square root will cancel. So really, essentially, this part is not there. So that's your equation. So that was one of your circled ones, I think, other than you have... Oh, I wrote a number wrong in there. Never mind. But either way, even though my number is slightly different, you had a negative 4 there, and I accidentally wrote a negative 2, but the same concept still exists. Okay, the only other thing you had with a circle, per se, was this one. It was x squared plus 4x plus y squared minus 6y minus 3 equals 0. Oops, 0. Okay, so what you want to do is you want to get your x's next to each other and leave a space. So x squared plus 4x. I'm going to leave a little space, put our y's together, leave a little space, and then any other number needs to move to the right, so that's going to equal a positive 3. What you want to do is you want to change colors, take your b value, divide it by 2 and square it, so 4 divided by 2 squared, and you can add that to both sides. So 4 divided by 2 is 2, 2 squared is 4. So you're going to add a 4 here, and you're going to have to add a 4 here. And then we do the same thing with this one. Take that number, divide it by 2 squared, and we're going to add that to both sides. So that becomes negative 3 squared, which is 9. So you're going to add a 9 here, and add a 9 here. Alright, I'm going to get rid of this stuff at the bottom. Okay, so then what you do is, let me change colors again. Okay, this side, the left side, is now going to be a nice circle equation. And what you're going to end up doing is this part right here, it's always half of that number that goes in the circle. So half of a plus 4 is a plus 2, half of a minus 6 is a minus 3, and then your circle equation is equal to the sum of all of this stuff right here. So 9 plus 7, which would give me 16. So if the question wants to know what is the center of my circle, it's going to be at negative 2, 3. If it wants to know the radius, remember we take the square root of this number, so the radius is going to be 4. Okay, so that's one of those. That's definitely on the exam every single year, so that's definitely something you want to make sure that you know. Okay, let me see. I'm looking at the pictures as I go through these. Okay, so you had one that said this x squared plus y squared equals 36, and y equals 2. Okay, all you're trying to do is go through and find the intersection of those two, and it looks like really you had your work necessarily to it. Honestly, to me it's easier if you just type it into Desmos and find the intersection. However, what you can do is you can plug in this number in for y. So you get x squared plus, in this case, 2 squared, which is 4, is equal to 36. So x squared is equal to 32. And you take the square root to both sides, so x equals plus or minus the square root of 32. So essentially, it's going to cross at the positive and the negative square root of 32, and then you know your y value to it. So it's going to have two intersection points, square root of 32 and 2, because it said y equals 2 on the second equation, and negative square root of 32 and 2. let's see. Okay, so this looks like some circle formula stuff. Okay. In this type of a problem, as soon as you see that right angle right there, okay, what that means is this section is going to equal to that section right there. So as soon as you see that right angle, that's one of your circle properties in Math 3. So in your case, yours was 15, which means that this one's 15. And it'll work for every single one like that. So even if, let's say, this part was 2, then that part's 2. Okay, you can find those hopefully pretty easy. But as soon as you see that right angle, it means it's dividing it evenly. It means those two parts are the same. Okay, so with the circle equation, this is kind of one of your other ones. Okay. If you ever have one that goes in and hits the other side, you know, like an angle on the inside that hits another side of the circle. Let's say if this is 30 degrees. Then this part right here is always twice that amount, so that would be 60 degrees. You know, or vice versa. If you had, let's say, this part is 80 degrees, then that part in there is 40 degrees. Okay, so that's one of the properties in circles that you want to know in Math 3. So your particular problem had, I think it said, this was 60, this was 100, and this was theta, I guess is what you were trying to find. I'm trying to read it on there. Well, instantly, if this angle right here is 60, then this is 120. And you know all the way around a circle is 360, so you just do 360 minus 100 minus 120, and then you should have your answer to that one, which is 140 degrees. Okay. One of the next ones you have circled, I'm going to clear this off of there. So you have this kind of problem. Okay, so what you want to notice, I'm going to put the other one in a different color, but anytime you have one of these interior angles and you have another interior angle that actually hits at the same spots, so like if I had one here and here, technically since these two lines actually stop at the same point, it means these two angles have to be the same. So for instance, if this one was, let me change color again, oops, didn't work, there we go. So if this is 10 degrees, then this is 10 degrees, okay? Those two angles are always going to be the same. Let's see. Oh, and then one of the other ones I see circled is right here. Anytime you have one that opens up to half of a circle, that automatically means that this is a 90 degrees because it opens up to 100. This right here, what it's opening up to is 180 degrees. And remember, these angles that go through the middle like that are always going to be half, so that means this has to be 90 degrees. That'll probably be on your exam, and your test as well. Let's see. Okay. Another property. Anytime you have a four-sided figure that's inside of a circle like this. This angle, and let's say this angle. These two angles that are across from each other like that are always going to add up to 180 degrees. Okay, so the ones that are across from each other are going to add to 180 degrees. So I think decently close to the one you sent me. Let's see, what was this? Looks like 70 degrees and X, and then you had Y and 50. Okay, so again, these two across from each other have to add up to 180 degrees. So this one and this one, if this one over here is 70, that means this one right here has to be 110, because they have to add up to 180. Same thing, this one right here, and this one right here. Again, if this side's 50, then this one has to be 130 degrees. It's the only way that it will work. Okay. Another one that you had in here is something like this. Okay, so same rule applies. This is still an angle that's cutting across your circle. So like if this is 30 degrees, that means this part right here is 60 degrees. And if this one's 150 degrees, then this right here is 300 degrees. Okay, so that rule still applies, and you'll see that in a lot of different stuff. I think that was most of these. I think so. Alright, let's see. Okay. So, alright, when you have one that intersects outside of a circle, okay, this angle right here is going to be equal to half of this larger arc minus the smaller arc. So I think in yours has this being 30 degrees, x, and 220. So if you can remember the formula, the angle is always equal to 1/2 the larger arc, which is this one right here, minus the smaller arc, which is this one right here. Now, what I always had students do is I always had them get rid of the division by 2, or the 1/2 part, by multiplying both sides by 2. So you get 60, and that cancels these two out. 220 minus x, and then some students will just go through and kind of figure out what that is in their head. So again, 220 minus what gives me 60? Well, that would be 160. Or you can go through and do the algebra part. And minus 220 to both sides, get the negative 160, and then change the sign. Let's see. Okay. Okay, so let's see. Centroid, add x's divided by 3, add y's divided by 3. Okay, so I'm going off complete memory here, but I'm pretty sure that the centroid one is the one that kind of divides it into 3 equal parts like this, or 3 parts like this. Okay, so I'm kind of going off of memory, but one of the things about a centroid is, let's say if this little section right here is 3, this one right here is 3. Well, this one right here is also going to be 2 parts of 3. Like this one right here, I'll change colors real quick. This one is the smaller section, whereas this is the long section. So if this shorter one is 3, then this divides it into 2 equal parts that are also 3. So, for example, if the question, let's say if this was A, B, and C, the question might say, well, if A to B is 3, what is C to A? Well, C to A is that whole distance, which would be 12. Or it could say, what is C to B? Well, C to B is 6. They could, like I said, they could give you, let me get rid of this. Let's say if they gave you, like this part was, I don't know, 8, let's say. Well, if that longer section is 8, then that means that's like a 4 and a 4, which means this section is 4. And then you could find, A to B, or you could find C to A. And I think that was all your circled ones. So I hope that helps.